Shut up and sit down.
Hi, I'm PJ McTavish and welcome back to another D.C.G tutorial. In this tutorial we are doing 2009 C-3, so surface geometry question. So straightforward enough, a little bit of conic sections involved here as well. So we're going to draw the given plan elevation first, we're going to draw the development of the conical surface, and then we're going to determine the true shape of that semi-parabola PV. Now for the elevation and plan, we have the curve PV in plan. So in plan you have semicircle, and then you have your parabola, because if you look at the elevation, the cone is cut parallel to the edge. So if it's cut parallel to its own angle, to its own axis, then it will give you a parabolic curve. So that should be straightforward enough. So fast forward through the elevation and plan, just bear in mind the scale 1:2. Before we move on, drawn and strong, we'll put in the, the cone is cut here, same angle of our cone itself. Now it's a parabolic curve, we look in here in plan, it won't be, because as you're looking down, it isn't. We do have a few points, so we know it is going from our vertex here, and this is a point over here, and I think they've labeled it P and V in our question already. So what we need to do is get a few section cuts through it and in the plan, project them up to the elevation where you can actually see where our heights could be, and then project them back down. So basically what I'm going to do is divide up 3060. I'll go through one point quickly, and then I'll fast through the rest. So if I quickly run through that, I divide up the plan here, the right hand side here, because the rest is just a normal semicircle. So this point here, divide up 3060. That cut there on the cone, or that line on the outside of the cone, project that straight up, find where it would have been on the back there, on the top and the elevation, join it back to the apex of the cone. This is important, so a little blue dot there. So I'm kind of going over my plan with this, with the apex of the cone. But that doesn't matter, because I'm just going to mark it in here. Where that line cuts through where the actual parabola is here, that gives you a point on that axis line here. So that's a point on my parabola. I'll do the same with this one here, and then it's symmetrical on the base. So this 60-degree line, draw it up, project it back down where it cuts, that gives you a point on your curve. Okay, so that is our plan elevation done, and that is part A. Part B now is the development of the conical surface. We're asked to draw the development of the conical surface. The join seam should be the shortest possible line. So, shortest possible line should be this line here. So that's going to be a seam line, so that's where we're going to break it over. Now, for a cone like this, for development of a cone, you need the edge view of the cone here. So what we're going to do is pick a center point here. We're going to have two radiuses. We're going to have this arc, we're going to draw this line, and then that radius here and that radius there is going to be the basis for our cone, because we won't see the top section of it. So I'm going to draw it over here out of the way, make sure it loads room. Okay, so what we've drawn there is the development of the cone if it was full without this cut section. So we have the apex of the cone here. This radius here is represented by the radius on the outside here, on the end view, or the edge view I should say. The full radius is the full length of our edge view of the cone there, and rotate it around. Now the seam is this section here, up to point V. So from there to there for point V. So what we're going to do is, as you see here, half of it will be by normal. So what we should do is divide up 30/60 and see where our points are. Okay, so by labeling our divided 30/60 plan here, we can find which radial line here is which. So points 3, 4, 5, 6, 7, 8, and 9 are all going to be on the outside radius. So I marked in V here, but I was wrong. So the distance from the apex here to the base there, that is our first radius. So V is actually the distance up to V there. So this is our seam from there to there. And we're going to have, actually most of this, oh, this will be strong down here. So the cut section is on our outside radius here. So some of our work is done for us already. So to get the next point, say point 1. So point 1 is here, and we found that point from our elevation up here. So we drew it out to hit the circle, projected that point up, joined it back down. Let's see, is it this one here? Joined it back down to the apex, where cut across the cut, that was our point. Now that height, if we rotate the cone around and bring that edge right up to the edge view, we'll get the height for the radius for point 1. We'll do the same with point 2, rotate it back out. So the points here, this is point 1 and point 2 on the curve here. String it out to the edge, show where it would be as a true radius, and mark that in on our development and finish off the development. So that is part B done. We have drawn the development of the conical surface, and the join seam should be the shortest possible line, which it is. It's a distance there up to B. So that is part B done. Next it says determine the true shape of the semi-parabola PV. On the true shape, indicate the positions of the axis and focus. Okay, so in order to do that, we need to find an edge view of it and project perpendicular to it to get a true shape. So in elevation, you see we have a edge view of the line PV of that parabola. So we're going to project perpendicular to it up here to the top right hand side. We'll put in our axis line, we'll put in our vertex V, our focal point, and then we'll find our points. Now we're projecting from the elevation, therefore this is an auxiliary plan. So we'll get our heights from the plan then for our point. So it says just for PV, so the distance from P to V, so we're going to get point 10 and 11 and mark that in as well. So we project out our line parallel PV here. Project out V, this is your vertex. This sphere here is actually the focal sphere of that cone, of that parabola. So the center point gets projected out again perpendicular, giving you your focal point on the axis. And the axis is just your center line. So this would be our axis here in plan. So what I'm going to do now is find point 11, the height from, so basically we're doing like, you do like an x1, y1 here. But we're working backwards from that. Rather than going distance from the xy line back to our point, we're going from the center line up. So this is our axis here in plan. Okay, so the distance up for y, or for 11, find that height here. Distance up for 10, find that height there. And then also P, and draw in true shape. So that's the question done. As always, I hope this helped. If it did, leave a like. Good luck in your exams, and we'll see you in the next one.